Welcome to this explainer. Today we're talking about evaluating prompts and why we really need to stop vibe checking. Okay, picture this. You changed the prompt. You ran it. The output looked pretty good, right? So naturally you shipped it. But then, 2 weeks later, a user reports that it's completely broken. Let me ask you, does that sound familiar? I bet it does. This brings us to section 1, the vibe checking problem and why trial and error ultimately fails. Look, most people improve prompts the exact same way they taste soup. You add something, you try it, it seems a little better, and you move on. But here's the fundamental problem. The soup is literally never the same twice. AI models are not deterministic. They give you slightly different outputs every single time you run the exact same input. So saying, well, version 7 feels better than version 6 isn't actually a measurement. It's just a guess. Think about it like this. Imagine you're changing a recipe, but you only bake one cake each time to judge it. You tweak the sugar, and hey, the cake comes out great. But was it the sugar, or did you just get lucky with the oven that day? You literally have no idea. And honestly, that's exactly where most prompt work lives. It's totally fine for a quick one-off experiment, but the second you ship something to real users, that approach completely breaks down. So, what do? Let's move into section 2, building a test set. Tiny but mighty. You absolutely need a test set. And the good news, it doesn't have to be massive. We're talking just 10 to 30 examples. That's it. For each one, you just need an input. The exact answer you'd accept is correct. What goes into this set? Well, you want the obvious cases for sure. You also want the edge cases that have broken things before. And don't forget those deceptively easy cases, the ones that look simple but have totally tripped you up in the past. You run the prompt against all of these and you get an objective score. So now, if version 7 scores 23 out of 30 and version 8 scores 26, well, now you actually know it's getting better. Now that we have our baseline, let's look at section 3, the repeatable evaluation loop. This loop is brilliantly simple. First, you change something, next you run the set. If the score goes up, keep it. If the score goes down, revert it immediately. And if the score stays the exact same, the change didn't matter, so just keep it. That's the whole shebang. It is boring, it is repeatable, and honestly, it's the absolutely crucial, really the only way to tell if a prompt is actually getting better or if it's just feeling better to you in that specific moment. You don't need anything fancy to get going. A quick custom script is totally enough to start. Just load your test cases, call the API with your current prompt, and print pass or fail for each one. But when you inevitably outgrow that script, there are some great tools out there. Promptfoo is open source and free for solo use. Or if you're using Anthropic, their console actually has a built-in evaluate tab. Now these tools don't change the underlying principle. They just make the loop significantly faster. Okay, moving on to section 4. Stopping silent regressions, which is really about stopping quiet failures. This right here is the thing that makes prompt work genuinely risky silent regressions. It happens like this. You add a new instruction to handle one weird edge case, right? And everything looks fine. But then, 2 months later, your prompt just starts failing on inputs that used to work perfectly. And the worst part is, you usually find out from an angry user complaint, not from your own internal testing. Fortunately, the fix for this is surprisingly simple. Treat your test set like a memory. It only grows. Every single time a user reports a bad output, you take that input and you add it to the set before you fix the prompt. Once it's in there, then you fix the prompt. Then you verify the score actually went up. By doing this, the set becomes a permanent record of every single failure that prompt has ever had. It literally can't quietly slip back into an old mistake because that mistake is already waiting for it in the test set. Let's dive into section 5. Judging the judge and why you need to calibrate your LLM. So, one more quick thing on scoring. A lot of people naturally reach for an LLM as a judge. You just ask another model to rate the output. And hey, it sounds really clever, but there is a massive catch. An LLM judge has its own weird little quirks. And a bad judge, it just gives you false confidence in all the wrong things. So if you're going to use one, you absolutely have to calibrate it. Here's how. Score 20 examples yourself first. Then ask the judge to score those same 20. Compare them. If they disagree a lot, well, either your rubric is unclear or the judge is just unreliable. And here is a real pro tip. Always ask the judge to explain its reasoning before it gives a score. Models that think first are way more consistent. Models that just jump straight to a number? Yeah, not so much. Finally, we arrive at section 6. Engineering versus guessing, the final verdict. At the end of the day, having a repeatable evaluation loop is the dividing line. It's exactly what separates prompt engineering from prompt guessing. You don't need a fancy research lab to do this. You really just need 10 good test cases, a reliable way to score them, and the strict habit of running that set every single time you change something. So I'll leave you with this question. What prompt are you currently running in production right now that you've never actually tested against a fixed sort of cases? That is probably exactly where you should start.